Okay, welcome to the second segment. It's question number 2. We are dealing with complex numbers. Given the complex number m and n, where m is negative 6 plus 3i, n is given by 2i plus 1, determine, write your answer in the form a plus bi. We must express our answer in a rectangular form. The first question, it says, what is the value of m bar plus n? Take into consideration this notation. It means conjugate. So where do you find m? This is your m here, minus 6 plus 3i. So what will be the conjugate of minus 6 plus 3i? You change the sign of the complex. So when you're looking at this question here, which part represents the complex? So the part that represents the complex, it is this one here. So what are you going to do? That's the part that you're going to change. You're going to change the sign of that 3i. You're going to change it to negative 3i. So for m, let me put it inside the bracket here. It is going to be negative 6. When you change the sign, it is going to be negative 3i plus m, which is given as, open bracket, negative 2i plus 1. Why am I using the bracket? So that I do not make any mistakes regarding the signs. So what is going to happen now in this case is that I'm going to add up my like terms. So my first like term is negative 3i and negative 2i. I'm going to put them together, negative 3i and negative 2i. My second like terms is negative 6 and positive 1. So this whole thing here, it simplifies to be negative 5i minus 5 as well. So if you want to rearrange it in that correct order, you can start with negative 5, negative 5i. So that is the order they are looking for. So this will be our correct answer here. And then in the second one, it says determine m divided by n. So in this case, we're not going to use any form of conjugate. We're simply going to use the original one which was given in the question. So m, it is negative 6 plus 3i. And then you're going to divide that by negative 2i plus 1. This is a division, so it means that we have to multiply this by the conjugate of the denominator. So the conjugate of our denominator, minus 2i plus 1, the conjugate is going to be positive 2i plus 1. So you're going to also divide this by 2i plus 1. Then let's do the multiplication. Let's combine them. So we're going to have negative 6 plus 3i, and then you're going to have 2i plus 1, and then this part also we're going to have negative 2i plus 1, and then multiplied by 2i plus 1. Then let's do the multiplication FOIL method. Negative 6 multiplied by 2 is going to give us negative 12i, and then negative 6 multiplied by 1 is going to give us negative 6. Then 3i multiplied by 2i is going to give us positive 3 times 2, it is 6i to the exponent of 2, and then 3i multiplied by 1 is going to give us positive 3i. So we are done with the numerator. In the denominator, negative 2i multiplied by positive 2i is going to give us negative 2i, negative 4, actually, negative 4. So it's going to be negative 4, negative 4i to the exponent of 2. And then negative 2 multiplied by 1 is going to give us negative 2i. Then the other one also is going to give us positive 2i. And then lastly, we're going to have plus 1. Great. Now we simplify, and then in the numerator, negative 12i plus 3i, they are our like terms, so I'm gonna put them together. So but negative 12 plus 3, it is going to give us negative 9. So we're going to have negative 9i. And then minus 6 plus 6 into -1. Remember, I squared is -1. And then when you go into your denominator, you will notice that 2 and -2, they give us 0. And then you're going to end up with -4 into -1 squared plus 1. Then when you simplify further here, you're going to have -6, -6, which is going to give us -12. That is -6 and -6 will give us -12, -9i. All of this is divided by 1 squared. -1 squared is 1 multiplied by -4, so it's going to be -4 plus 1. So -4 plus 1 will give us -3. Now, you can leave it here, or you can just separate your fractions. So you're going to have -3, -12 right there, divided by -3. And then also you're going to have -9. Yes, -9 divided by the denominator there, it's -3. And then this is I. Let's not forget that. Oh, I, it's on 9. Oh goodness. Then this part is going to give us 3, 6, 9, 12. It's going to give us 4. And then this part, negative and negative, they're going to give us positive 3i. And that will be our solution for that question. Then proceeding on to the next question, 2.2, they say the alternating current circuit has one impedance given by 3√2 and minus I√5. Represent W in an Argand diagram. So we have our Cartesian plane here. So this part represents the real axis and this one represents the imaginary axis. Now for you to be accurate when you're drawing this Argand diagram, just find out, convert all of these numbers into decimal. So 3√5, just so you can see which one is bigger than which. 3√2, it will give us 4,24, and then the square root of 5 will give us 2. So the root of 5, we know that it is smaller and it is imaginary. So you can estimate the root of 5. It's negative, so you can just estimate it to be somewhere here and have the negative square root of 5. That will be your smaller value. And then your bigger value on the x-axis, 3√2, you can estimate it to be somewhere there and have your 3√2. Another thing that you can do is you can just count the blocks. It's okay, but a proper estimation should also do. Now where the two meet, they meet somewhere here. That's where you're going to draw a straight line all the way to that point there, and then do an arrow there. That should be your Argand diagram. Done. You are done by so doing like that. And then calculate the modulus of W. The modulus of W. So the modulus, we can just use this. W, it is equals to the root of a squared plus b squared. Okay, so let's just use r. R will be then equal to the value of a, it's this one here, which is going to be 3√2 all squared plus b, which is going to be the root of 5 squared. Put the negative there if you prefer, and then put the whole thing in the calculator. Use the calculator, then you'll have the root of, open bracket, 3√2 all squared plus, you open bracket, the root of 5, and then all to the exponent of 2, and then it's going to give us the root of 23. So our r is going to be the root of 23. Nice. Then in the next question, this question proceeds in the next page. They say calculate the argument. The argument, you're going to say tangent of theta, it is b divided by a. So you're going to say the tangent of theta equal to b. If I remember very well, the value of b, it is negative √5 there, all divided by 3 √2. So already we have a negative, so that means you're going to start with your reference angle. Your reference angle is given by the arctangent of the whole thing here. Please keep it positive. √5 divided by 3 √2. So use your calculator. Clear. Press shift and then tangent and then fraction and then √5. Then you divide it by 3 √2. Then okay, the calculator, make sure that your calculator is in degree mode. Mine is not in degree mode, so let me just change the mode of my calculator. Let me change the mode of my calculator. Shift mode from degrees, from radians to degrees, equal to 27,79. That is the correct value there. So that means our reference angle here, it's going to be 27,79. Let me remind, 79. Yes, that is correct. 79 degrees. Now this is not my final answer. It's a reference angle. So if you remember in our Argand diagram was in the fourth quadrant. So that means theta, it is equal to 360 degrees minus 27,79 degrees. So then your theta will be equal to, go to your calculator, say 360 degrees minus 27,79. And then you get 332,21. 332,21 degrees, and that is our angle there. We are using 360 degrees because we are in the fourth quadrant. Then the next question says represent W in the form RCs. So W, it is equal to R. We got the R as the square root of 23. And then you can say CIS theta, it is 332,21 degrees. And that is the a simple transformation from rectangular form to polar form. So this one here is written as polar form, just direct substitution. And then 2.4, solve for the values of x and y in this equation. Okay, let's start with the real parts. Let's see what's happening. So according to my equation here on the left, -4 is the part that is real, so I'm going to put -4. And in the part that is real, it is 2y, I mean, it is 2y and minus 6x, I'm going to call this equation number 1. Equation number 2, let's observe what is imaginary. The part that is imaginary is going to be 2x, so I'm going to put 2x here. And then minus 1. Where do I get minus 1? From here. So that is minus 1. It is imaginary. This is equals to negative xi. This is the part that is imaginary. So this is imaginary, imaginary, and imaginary. So imaginary is going to be negative x. So from the imaginary, since I only have one unknown, so I might as well start there and solve for the value of x. So this part is going to be 2x plus x equal to 1. I'm going to transpose 1 to the other side. Then I'll end up with 3x equal to 1, which means that the value of x is 1 divided by 3. So if x it is 1 divided by 3, I'm going to substitute into this equation here. I'll have my negative 4, which is equal to 2y, minus 6 into 1 divided by 3. That means negative 4. It will be equal to 2y. Negative 6 multiplied by 1 divided by 3 is going to give us negative 2. Take it to the other side is going to be positive. So negative 4 plus 2. This will be equal to 2y. Then this will give me negative 2. It is equal to 2y. And then you divide both sides by 2. That will mean the value of y, it is equal to negative 1. That is your simple straight answer right there. Great. Okay, the next segment will continue immediately right after this one.